head over to your Google Chrome, you can just search for Remix Ethereum. You'll see it will come up over here, remix.ethereum.org. Please be sure to just remove the HTTPS in your URL, as it can have some issues when compiling. So we will just use HTTP. Alright, as you can see, I've obviously got a few workspaces already. What we'll do is we'll create a new workspace for this tutorial. We'll call it Tutorial Coin. Immediately there's a new repository that gets created with some very standard scripts, tests, contracts, and some remix tests. What you'll already notice is there are a few files with their file extension called .sol. It's for .solidity. So what we'll do is we will create a new file, and you can call it whatever you want. I'll call it ERC20. Tutorial. Alright, awesome. First of all, we will import Solidity. And the version that we'll be using today is 0.5.0. Alright, so just a note, I'll be making a lot of notes here. You do not have to put in these notes, but it's obviously very good practice to do so. Now this is an ERC20 standard interface token that we'll be developing. So what we'll do today is we will actually focus on 6 functions of the Solidity programming language, the 6 basic functions that are needed. And what we'll do next is we will actually declare them at the start of our contract. Contract ERC20 interface function. First function that we declare, total supply. UINT. Now, if you would like a full video of exactly how these functions work, you are welcome to let me know in the comments, and I'll put together a Solidity introduction course. This is based on an assumption that you have got some sort of understanding of either Solidity or a similar programming language, and that you can actually just follow along. Don't worry if you can't follow. If you just like to see the way that we construct the smart contract, that's fine. I will be posting this Boolean success. Right? Sorry. Awesome. Event transfer. Oh, this is just to specify an event where there's a transfer of our tokens. Just enable that functionality. Indexed from, as well as indexed to index 2 and then int tokens. Now let's add this to make sure that we get approval from the network. Awesome, and we are ready for curly bracket to end that off. Alright, now the next section we will just be writing a function with a specific algorithm, just so that we can ensure that the safe math library is actually executed and that there's no double spend that could occur. So first of all, let's do some good practice. Input safe math library. Alright, so first of all, let's import the contract, let's declare, now we add the functions. Function safe sub. If you're not familiar with the safe math library, I highly recommend looking at a few tutorials. So we just declared two variables, uint A, uint B, that we'll use in the tokens. And next we'll have a look at the returns. We'll return the uint C, so public here returns. And once again, in Solidity you'll see a lot of coding terminology that is used in Python, C#, and JavaScript, but then also you'll see certain terminologies that are very, how can I say, native to Solidity, which makes it such a strong coding language. Alright, so C equals A plus B. Alright, and we require C to be larger than or equals A. Alright, now outside curly bracket, the next condition, the function also within safe sub, same story, uint A, well, uint B, require should be smaller than or equal to A. condition C is equal to, just think about it, A minus B. And add curly bracket and safe multiple. You want A, comma, B. Public returns UINTC. Curly bracket, then C is equals to A multiples B. Now, my apologies if you're not following the logic over here yet. It will make sense in a moment once we start using the variables. However, I do recommend familiarize yourself with the SafeMath library. Not SafeMath, SafeMath. If this is the case, let's see. C is equals to A multiple B. Right, and then require A is equals to B. Require to another coin, which is not good practice. In general, 18 decimals are recommended. However, for this tutorial, we will just use 9 decimals. Okay. Right, total supply. You can see it comes up. A tutorial coin. Now, UNT, to specify total supply, we actually need to bring in the SHA-256 hash algorithm, UINT256 public total supply. Smaller than Alright. So as you can see here, next we will need to bring in a constructor argument to actually assign values to these variables that we've declared. So it's actually still within the same curly brackets that we have here. So constructor public, and this is a function, curly bracket, open name is equal to, here you can give your coin a name. So this is the official declaration of your name. So tutorial coin, let's stick with tutorial coin. Symbol, what should we call it? TTC, decimals. And again, over here it really matters the number of decimals. If you put in 18 is actually recommended, which means you will have 0,18 zeros before your first value. However, for our tutorial coin, we will just have 9 decimals. And then finally, total supply. So I want 10 million, 10, 1, 2, 3, 1, 2, 3. 10 million total supply. Tokenomics is a whole different discussion, and this is a very important little constructor function that we built in here when it comes to tokenomics. Today we're just focusing on coding and building our own ERC20 token on the Solidity platform. Alright, so next we'll have balances msg.sender equals total supply emit transfer is 0. My sender address. Total supply. And we are done with that section. Alright, so now on the same level, we should bring in the function of total supply. Right. So, by the way, I'm just looking here at the next function that we're focusing on. And remember, this whole smart contract will be done in about 90 lines of code. So congratulations if you've been following. We are more than halfway to creating your first, or maybe your second, or maybe your 100th smart contract on the Ethereum network. Alright, function total. Spender. and we finish off that function. Next, function of prove. We need address the spender as well as in the UINT of tokens. Alright. Next we need the return public returns. Remember it was the Boolean success. So when do we need this type of return? So when it's allowed msg.sender as well as our spender those tokens. Emit approval msg.sender spender tokens. This is actually one of my favorite parts of building a smart contract, just because Solidity is such an effective programming language. Let's just go through logic, function approve, allowed message sender, spender tokens, emit approval, return true. So we are done with it. Here's our problem. Alright, so far we've got some neat looking code. Function transfer, leave next. Need address 2, UINT tokens. Returns. Right. Now, this one is quite important, so we need balances. msg.sender. Okay, now we call in our save sub function that is declared above from think about this, something does not look right. Save sub type bracket. So let's see, balances, then block bracket, sender, and then we need the tokens. Then balances 2, save, add. We need the save sub function again, balances. Alright, from and then tokens. Tokens. Need another balances from. Bring in our image symbol. Save sub. Then we allow from msg.sender should work from tokens. And finally, balances carried over to through the save add. Save add. Transfer finally from to transfer tokens. Return 2, and that is it. Suspect got 1, 2 levels, too many brackets. No. That is it. Thank you very much for watching. I will be uploading this to the Programmably GitHub. Find the link in the description below, and be sure to like and subscribe. If you'd like to see more of these videos, let us know what you'd like to see. We will also be doing a ERC20 token, which is very much the same. And we will also take you through the whole journey of smart contract creation. Like I said, we'll compile it in the next section, add it to a MetaMask wallet, and also deploy it onto the network.